Whenever I saw, call for talks or whatever for people people to come and volunteer to give a talk, I only thought of a couple of topics that I thought would be kind of like novel or something like that that you haven't already heard a lot about. So one of the things that I've learned a lot about recently is how to build good applications with good code that's scalable and has a clean architecture. Those are all concepts that I'll talk about a little bit. The question though becomes like, as a developer, how do you think about that whenever you're building an application, especially when you're scaffolding it from the ground up? So first off, a little bit about me. My name's Devon. I am a self-taught developer. My current role is Director of Product and Technology at SendaRide. We're a rideshare platform for non-emergency medical transport, which means we help get people to their medical appointments, primarily the poor and the elderly, and we do that through a platform that matches third-party care partners who are trained and vetted and then perform that for us. And then in my previous roles, I've just been a normal software developer. I jumped into the development world through JavaScript, so it's my favorite language. It's the one I know the most about, and so, but I have a little bit of experience in trying to re-architect some legacy code, and in my experience, I've found the tools of both domain-driven design, which is like the big level concept we'll talk about today, and then the practical how-to of using TypeScript to accomplish that. And then I'll give a little bit of kind of the features of TypeScript and how that kind of plays itself out. First off, who here has experience with TypeScript specifically? So very few, minority of the room, I would say. So we'll definitely get into what TypeScript is. To kind of give you context for where we're going, TypeScript is just a superset of JavaScript. It transpiles directly into JavaScript. So for all intents and purposes, when you interact with TypeScript, you're just interacting with a statically typed version of JavaScript. And so everything else works the same, all the features are the same. And so we'll get into a little bit of that as we go on. So kind of where I'm coming from, so in my current role, I think a little bit more about from the business perspective, right, and the product perspective. So whenever we think about building applications in JavaScript, we're also thinking about, from my perspective, I'm thinking about, okay, how does this scale? How does this get bigger? How does this take on more users? And how do I hire on developers who can jump into this code base without, losing their minds completely? So I want to give an overview of how kind of the philosophies of design-driven development, which are just a kind of a philosophy, and I think a really good framework for how you build good code, and then also TypeScript and its features, and I'll show a couple of examples of how that plays itself out in TypeScript too. So the first thing I want to say is that I have a confession to make. I once said that switching to TypeScript was the worst mistake that the Angular team made. And I have to say that I was completely wrong about that. So whenever I said that, what I kind of thought about was whenever React and Angular were taking off, front-end frameworks that are both JavaScript-based, React took off much faster than Angular. And about the same time, Angular switched from AngularJS, which was completely JS and directive-based, to a TypeScript form. And I thought that was a big mistake for the project itself. I thought that the adoption of React was a lot higher, and that's true to a large degree. But I think when it completely depends on what perspective you're coming from. I think that for a large-scale organization with a very complex front end, Angular is a fine framework to use and a very scalable and maintainable one. So I have this slide because I kind of wanted to say that I'm not coming at this as like this old school Java developer who's like has all these really, really strong opinions about like how you execute, the development of maintainable code. I'm self-taught. I'm coming at this from a completely different perspective than most of the people that you'll read from like domain-driven development or clean architecture, all these concepts that you'll hear about. Which, by the way, I encourage you, a lot of these don't glaze over these large kind of concepts. They're all important, and I think as devs, as a member of the tech community, I'm passionate about seeing more of our devs become product-minded, business-minded engineers who can then jump into these large code bases and bring value with the best of them across the nation. So, if anything, I think that it's important for us to know and continue to learn about. I mean, learning is more of a continuous activity than it is just a one-time thing. These aren't things that you have to understand right now to gain value from this. So I absolutely love JavaScript, like I said, and the beauty of TypeScript is you can work with it with any JavaScript framework. So I've worked in a React Native project that was built in TypeScript. I've worked with Angular, and I've worked in a API framework called Loopback 4, which is very domain-driven in its philosophy. So I'm coming from all these perspectives. I'm coming from the perspective of a developer. I'm coming from the perspective of someone part of the community, a product person, business person, all of that. So the first concept I was going to go over is domain-driven design. Again, don't gloss over this. This is a very complex, this is like, if you Google this is probably the first image you'll see. The whole idea behind domain-driven design is just that the entities of your problem domain, in other words, the concepts of the business problem that you're trying to solve by building an application, that should drive how you architect your software. Now, that becomes a little bit more clear as you actually architect your software. So that's like the big level idea. Kind of breaking it down a little further, the idea of clean architecture, or layered architecture. So this is the idea that whenever you have an entity or some bit, let's say a customer, an order, or the concepts or the mental models that your users have that drive the building of your application, there's a certain architecture that helps you accomplish that in a much more clean way. Again, there's a lot to this, so I'm not going to go through all of this, the whole data flow and dependency rule. All this is pretty much saying is that there's certain rules based on how these architecture layers interact with one another, and that makes for a good application. And then the next thing is, this is kind of the namesake of the talk, was the solid principles. These are just principles, as most of you probably know, are principles of how you write classes and things like that. Things that we can now do in JavaScript thanks to ES6 and then TypeScript also. And so these help us to create code that you can test easily, that you can jump into and understand what's going on, and that you can refactor without a ton of headache. So as developers, we all want to do that. Okay, so kind of, again, high-level overview of some pretty major concepts. This kind of going from the big to the small. So again, I encourage you to take a look at those types of things. And I know some of us, we consider ourselves more hacker types. We build apps on the side, and that's the reason JavaScript is so amazing, is because you can put together an application so quickly now, and you can have an entire stack deployed very quickly. And so those are real big benefits to JavaScript. So again, this is coming from a perspective of, I want to see people who are like world-class engineers in our context who can hang with the best of them. So a little bit more about what TypeScript is. Again, it's a superset of JavaScript. It's static typed, which means that you define your types within the declaration of your variables and all of that, which I'll show here in a little bit. And then it also transpiles directly to JavaScript. So you have a folder that has a bunch of transpiled JavaScript. The beauty of that is that whenever you write in TypeScript, you're able to build it and then jump over to that folder if you have any issues and look at the JavaScript directly. In other words, it's not like you're compiling to assembly where you don't have a ton of access to, or bytecode or something like that, where you don't have a ton of access to the resulting code or the object code. This code you can jump into and troubleshoot as well as with the source code. It's source to source, in other words. So at this point, it's kind of like, all right, that's cool, but why? Why go through all this trouble? What is all of this? The biggest thing to me that I found, and as a self-taught developer, whenever I'm helping other people learn JavaScript, the biggest thing I always say is that JavaScript is easy to learn but difficult to master. And it has to do with this quote right here at the bottom. It says, the strength of JavaScript is that you can do anything. The weakness is that you will. So I think that what we're trying to achieve is the ability to jump into something, rapidly create applications with JavaScript, and then also find ways to maintain that in the long run if that happens to be an application that scales. I don't think anyone would build an application not wanting it to somehow gain traction or get bigger. That's kind of the goal, right? So then someone might say, well, we have a lot of these features that you can accomplish, this domain-driven design, all these cool things that you're talking about, with some of the features that some of the other ECMAScripts have given us. Like with ES6, you can declare classes. That gives you a little bit of syntactic sugar to work with, solid principles and all of that. There's also the flexibility of JavaScript, and then there's also rapid development. These are all concerns that I think are somewhat separated. Rapid development is a good thing that you should be able to do, but then also there's a point where everything transitions, right? So you want the flexibility and all of that. But then you also need to get to a point where you limit the scope of what you're working with in order to be able to further it in its intended purpose. And that's where I think that's where I think these ideas, these big development concepts kind of come into play. So let me just kind of get to it. Basic features of TypeScript, you can declare your variables in specific types, and I'll show you what the syntax of that looks like here in a moment. They have basic types like number, string, boolean, an array, and object. You have some non-typical JavaScript types like enums. You also can declare functions as returning void, which is no type at all, meaning it's bringing back nothing. Your falsy types. You also can declare interfaces. So if any of you are possibly coming from, a C# background or something like that, then you can declare interfaces in order to make sure that your objects are adhering to a contract. And so you know that whenever you're receiving an object from like a function call or something like that, that it has certain properties and all of that. Function types, you can declare what the parameters of the incoming, what the types of the incoming parameters for a function are, as well as its return value. And then also classes, and classes can act as types also. So I'll jump over to some examples right here. So let me do this. All right, I'll make that slightly bigger so we can see it a little bit better. All right, can everyone see that in the back? You good? Okay. So the basic syntax of what TypeScript looks like is you have your typical sort of JavaScript declarations. And then it works, all the basic structural syntax and compositional syntax is all the same. You'll notice that one of the features is that you have the colon syntax, which is your type declarations. So here it's I'm letting sort of the transpiler know that this particular variable has to be a string. So you'll see right here if I try to reassign it. Then that will throw an error. And to illustrate that, not only will it throw an error, so in order to get this over to JavaScript, I have this TS file, and TypeScript's just a node package that allows you to write and declare these TS files, and then it creates an output file. So this is the output file. Here so this is kind of like a package.json, but it's tsconfig. It tells the transpiler what everything that's going on that I want. So I'm telling it my output directory, which is this build directory over here, right here. And that gives me my resulting JavaScript files. And that's what I would deploy as my application. So anyways, that's just a little bit of the nuts and bolts. Whenever I actually am done writing my code, I can just run the TypeScript command, and it's going to transpile that and change it. So you'll notice here that it says cat. If I, change this to say cat2 and save it, right now this doesn't say cat2, but if I just transpile again, then this says cat2 here. So essentially, what's going on is that there's a lot of checking going on as it's transpiling all of that to the target JavaScript. So, and then the other thing here is that you'll notice that if you try and go to a different type than what was declared, VS Code being really hand in hand with TypeScript as a Microsoft product, will tell you and give you that error before you actually transpile. And also the transpiler will not, I guess this one will allow, let me save that, make sure. So you see that this actually throws an error saying that you can't do that, and so the resulting JavaScript hasn't changed since I last saved the file. So this, you can probably see how in a large code base this would already come in handy in terms of not getting the wrong types. I know that especially in JavaScript, something that I've dealt with a lot is like null checking and checking for properties in an object, or even just assuming the type of a particular variable, and then that eventually will cause problems that are somewhat difficult to troubleshoot in the future. The next kind of thing I'll go over is interfaces. So everything in TypeScript results in just a normal JavaScript data structure or type. So whenever you see like interface or something that's a little bit different in terms of its syntax, all that's going on is it's resulting in an object of some sort. In this case, the interface is an object that's a contract, and that objects of that type have to adhere to that contract. So in other words, here I can tell that if I create an object of feline type, that it has to have this type. That type can only be of these enumerated values. So in other words, I can't do something like, I think I might have an example down here. But like I could not change this to that. You'll notice it is already showing me that I'm not assigning that property of that object with the correct type, so it's already throwing an error, and it also won't transpile. So it has to be of one of these enumerated types. And then the other thing is I can't do something like this, and then like that. So you'll notice a test object does not adhere to the feline contract at all. It doesn't adhere to the feline interface. So if I declare with let that pet lion is of the feline type, I can't assign that object to that variable at all. It won't let me do that. So I think I might use that variable in another place too. So as you can see, it really helps you limit the scope of what you're doing, and helps you kind of think through how you're constructing your objects before you actually start writing code that does so. To add on to that, I would also connect that back to kind of domain-driven development, in the sense that when you're thinking about how to build an application and all of the business concepts that go into what the problem is that application is trying to solve, then I know that in the past, the first thing I'll do is just start creating types in TypeScript because it allows me to communicate to my other team members exactly what is going on, what the properties of that object are, what a request looks like, what a response is supposed to look like, all the things that we normally deal with as JavaScript developers. Real quick, I'll just kind of jump through this and then we'll get to the pizza time because I don't have a whole lot left. So with functions, you can see that you can say what the parameters are supposed to be of what the type is. And then something I'll point out, another interesting thing about JavaScript and the way it types inherently is that, this operator is an overloaded operator in JavaScript. You use plus for both concatenating strings as well as adding numbers. So have you ever run into the issue, if you haven't, then, God bless you, where you are, the type is coerced in JavaScript. For instance, if this came in as a number, and so then, or it came in as a number, imagine input comes in as a number in just normal JavaScript, and it converts that to a string. So your resulting string might be like the string of 0 plus, and then whatever is concatenated. In other words, with the help of TypeScript, really helps you it helps you kind of get over some of the other benefits that I see of JavaScript, benefits or detriments depending on how you look at it. There's a lot of really hard to troubleshoot things that TypeScript helps you out with. The same is true with the interface type. So with change feline, if I'm expecting the feline interface, an object of that type, then I can't pass in like the test object. It throws an error before I get to that point because it's expecting that. That it comes in with the right properties. Because in that function, I'm probably expecting certain properties. JavaScript will throw an error saying, this property doesn't exist on this object, all of that kind of thing. So, and then the other thing is that I know that this function, I'm declaring that it's returning the feline type. So I can also declare this as a feline type. It's inferred, but you can also make it explicit to help other developers out. So, if this function was an imported function, then I would know as a developer that this is of that type and then use it as that type instead of having to dig through the code or infer. The last thing I'll kind of mention is classes. There's a lot more to cover with TypeScript. There's also advanced types. There's also different operations. One thing that I'll kind of cover really briefly is decorators. Decorators are extremely beneficial for applications. And if you've ever worked with Angular in the TypeScript world or even looked at Angular code, you'll notice or you'll be familiar at least a little bit with decorators. But the one thing I'll say here about classes is that classes, because they have properties that are predefined, you can use those in the same way that I was using the interfaces earlier, right? So because, and this kind of goes into like inheritance and things like that, but animal has a property name, right? Property name is a type of string. I can also extend that class to specify it, to make it more specific. So now I have a class dog, and it's going to inherit the name of its parent class. And so then what that means is that whenever I create a new object of that particular type, then I know that it will have the same properties. And not only that, but I can also use that in my code as a type. So in other words, in the same way here that I use feline as a type, saying I'm expecting a feline object, I can also say that is of the dog type or whatever, because and know that I have those certain properties and methods coming in from that class. And I'll go ahead and switch back over to this. So kind of tying it all together. This is a really cluttered code sort of example, but the thing that I want to point out is that with TypeScript, it gives you a lot of the tools that you need to actually accomplish these, creating this clean code. Loopback 4, I encourage you all to look into that. It's an API framework that allows you to, is broken out in the same way that domain-driven design is. So you'll notice a couple of things. You'll notice the whole concept of a repository. You'll also notice in the constructor, the inject decorator. Those two things are both domain-driven design concepts. So essentially it's saying, I'm going to access this data through specific rules. I have to bring this particular service into my application in order to use it, as opposed to just accessing it directly or writing a query in this method. So it allows the code to be separated and more expansive. Also, the decorator there is, all that's saying is that whenever this particular class gets instantiated, so in other words, whenever I say new account repository, there is going to be some service out there called data source, DB data source, that has already been created for me at boot time of the application. And then that is then going to get injected into my application for use. The benefits of that, it goes back to anyone who's ever done any sort of unit testing or refactoring of services in a particular application, that decouples this particular bit of code from that service, all the functions in that service that I created, which is the whole point of the D in solid, dependency inversion. And so that, with the help of the decorator, I'm able to, the application boot, it news up and creates an object of DB data source type, which is at the very end of the constructor you'll see. And not only that, but with TypeScript, this class knows that it's receiving a DB data source type. It's not just some random object. In JavaScript, I can inject whatever I want in that. But with TypeScript, it helps me know that this is a specific class that I'm expecting here. And then whenever this account repository gets instantiated, it then is able to receive that. That was a really complicated example. But I think at the end of the day, I think my humble opinion is that when we're thinking of JavaScript and its future in scaled business architecture, we need to use the tools that are available to us. As any developer, we have to find ways to take sort of the mental load off of us, so we can remember fewer things and then be able to create better, cleaner code that we can jump into. And then if you go to a new job or something like that and you jump into that code, you'll want that to be better for you. I've written plenty of bad code. There's some poor souls supporting stuff that I've written, and had I had these tools and concepts available to me earlier on, then they would be dealing with much different issues, better issues to actually spend their time tackling than just figuring out what I wrote. So a couple things. So with resources to this type of stuff, there's all sorts of stuff. It's obviously, I'm not going to give you a link to click on, but what I would tell you to Google if you're taking notes, Khalil Stemler has a fantastic course over how to accomplish domain-driven design and clean architecture in TypeScript, and his site is really, really good. And also, I didn't want to go through a bunch of how to set up TypeScript because there's plenty of great tutorials out there. And so I would just encourage you to look at that, maybe go to the TypeScript Lang website, or just Google maybe a free code camp one or something like that. There's plenty out there of tutorials on how to go through that. So with all that, I'm sure there's some questions, or maybe there's not. Maybe people just want to eat pizza. Yep.
All right. So I've used TypeScript in the past on an Angular 2 project. One of the things I really struggled with was pulling in dependencies for projects that both had TypeScript typings, I think would be the right word, and also projects that did not. And like I said, I just really struggled with that. So could you walk through kind of how you would add in a dependency for TypeScript? And then let's go the easy route and say that there are full-blown typings, like it's jQuery or something, And then how would you approach that from like a custom library that, let's say, someone built that did not have that, like
Right.
the TypeScript typings?
Yeah. So the first thing I'll say about that is that the good thing with TypeScript, as opposed to something that's a completely different language than JavaScript, such as Dart or even like CoffeeScript, I believe, works similarly, is that everything is just JavaScript, right? So what that means is that someone who's maintaining some open source library, all they have to do is add what's called a declaration file. And I would pull that up, but I'd probably be kind of stumbling around. But essentially, with TypeScript, all you have to do is add a whatever you want the file name to be, .d.ts, and TypeScript knows that that's a declaration file of types. So a lot of maintainers are getting to the point where they will go in and all they have to do is add that type of file. So when you pull it in, all you have to do is TypeScript will automatically start getting those types. Now, that's because of the nature of open source. That can be really challenging because some people aren't going to add those. You may have to add those yourselves or fork the project if you really want to, if you're really committed to creating those types. But the best libraries that we've worked with, or the best packages that we've worked with, already have those. And actually, in my experience, the major players that I really needed those types because there's a lot of complex relationships and things like that, I actually found that those were already done. So I think time will be beneficial to that project. Does that answer your question? Yeah. Yep. Anything else?
Yeah, really good presentation so far. I appreciate you. Question I have is, I've always struggled with getting unit tests to run within TypeScript. Do you have any like tips or tricks or favorite frameworks for unit testing within TypeScript?
I will tell you that I have very limited experience with TypeScript unit testing. The thing that I'll say is that most of my experience is in the Loopback 4 framework. And Loopback, the way it's written, it provides a lot of kind of the upfront work that is needed to, like new up these objects in order to inject them. So like, for instance, if you're like stubbing a service, right? Their sort of built-in unit testing will kind of do all that for you. So I think my encouragement would be, well, I probably need to dive in on how to do that just with TypeScript myself, so I don't really have a lot of encouragement or guidance from that perspective. But there are people who are writing in frameworks that allow you to do that. I think that the testing, I don't know, Angular uses Protractor, I believe, so I think that like the unit testing in these different frameworks kind of knows that going into it and has that built in. So that might be the place to start, is to try with like an Angular project or a Loopback 4 project, just one to mess around with. Both of those sites have like a tutorial step-by-step that goes through all the concepts of it. And then I think that there's testing sections for both of them, for Angular and Loopback. So that would be maybe the best way to dive into that and see how they're doing it. The thing is that to accomplish that and do it well where it's easy for us as devs to use takes a lot of upfront work. So it's really hard to replicate in like, just like a side project or like a dummy project that you're working on,
Okay, thank you very much.
Mm-hmm.